So we're looking at Pythagoras. Pythagoras was being used in different scenarios to work out certain unknowns, all right, as part of circles. Now, that's a wee bit of a weird one, but there's certain rules that we'll add to as well. There's certain rules within circles that allow us to use things like right angle triangles to find unknowns. So the circles we were looking at on Tuesday, okay, we were looking at something called the chord of them. And the chord is just a straight line that cuts through the circle that isn't the diameter. So the straight line does not cut through the center of the circle, okay? The straight line cuts the circle, touches side to side, okay? And we're able to use certain rules off the back of that to work out certain problems. So enough talking rubbish. Let's have a wee look. Okay, so as you have a wee look at that one, so hopefully either you've copied it down or you've managed to have a wee look. I'll open it up. Well, there's last week's, we'll see the fear. If you're wondering why my iPad looks bizarre, it's because it's my wife's and she's a primary teacher. So there's lots of wee kiddie things on it. But I like the way this works, so we'll use it. Okay, so let me just add in that photo. Cancel that. Oh, it's been all right. All right, so that's the question we're looking at. Everyone see that okay? Nice one. Okay, so in front of you, you've got a circle. Okay, now it's got a chunk cut out of it. Okay, but if we were to continue that circle round, it would just look like that. Okay, so when you see a question like that, you've got a circle and you've got a line that cuts through it. Now that line doesn't go through the diameter, that becomes important later on. Okay, so that line's not cutting through the diameter, it's cutting right through the circle side to side. Okay, so line A to B is 9 centimeters long. Okay, now with a chord, when we're talking about it, if we take a line from the center of the circle to where it touches one of the outside edges of the circle, okay, so in this case, that O position, okay, that O indicates the origin, the center of the circle, okay. Now O to B is the radius, okay, so the distance from the center circle to the outside of the circle, if it's a straight line, is called the radius, okay, so O to B is the radius in that case. Now if we take another straight line from the center of that circle and take it vertically downwards. Oops, what's happening? Take it vertically downwards. Should have done that in another colour probably. What that line does, it cuts that chord in half, but it also creates for us a right angle triangle. Okay, and that is where Pythagoras comes into it. So if we've got a right angle triangle, and only when we've got a right angle triangle, because we work with non-right angle triangles as well later on in the course, okay, so only when it's got a right angle, an angle of 90 degrees, okay, we can do that. Now, I seen it was a chord question and I've set it up as such, okay, but let's have a wee look at what it's asking us to do, okay. So diagram of the label, it's asking us to find the full height. The full height, okay, is indicated there, okay, is the bottom of, or where that chord starts, through the centre and right to the top of that, okay, that red line, okay, that full distance there. Now, we have enough information now to find out that part of it, okay, that side by using Pythagoras, or a squared equals b squared plus c squared. Okay, with that, and once we find that out, we can then add the radius. Okay, so the radius is just the distance from O to B, O to the outside edge. Okay, that bit. So once we find that red line, the length of that red line, okay, we can add it to the radius, and that will give us the total height for that label. Okay, so let's just do that. Tidy that up a wee bit. Right, so taking that triangle, I was trying to draw it out, but for life me, we're going to how to do it. We've got across from the right angle, okay, so opposite the right angle, we've got the 6.6 centimetres, the radius of the circle, okay, again that's given in the question, will be the side opposite the 90 degrees is always the longest side. It's known as the hypotenuse. The longest side of a right angle triangle is the hypotenuse. Okay, so it's that long side squared is equal to the two shorter sides squared. Okay, more common way of writing that, a squared equals b squared plus c squared. Again, these are just letters to use. Don't worry too much about it being A, B and C, okay, and how they apply to the question. Remember, they're just letters that we use to indicate unknowns, okay. Most important thing is long side, the hypotenuse squared equals short side plus short side, okay. So we've got hypotenuse, we know what that hypotenuse is, so we've got 6.6 squared, that's equal to short side plus short side. Now, one of the short sides, that one there, okay, is unknown. We don't know what that is. The other short side, the bottom one, we can get that length because the line we've brought down from the origin, the centre of that circle, the line that we've brought vertically down has cut that chord straight in half. So that distance A to B is 9 centimetres. So if we've cut that in half, that means that side of the triangle is 4.5 centimetres. And then plus c squared, we're left with that. Okay, so that's our red side. We want to find our unknown. Remember, we can just flip the equation around. If it's a side it's got an equal sign in the middle. So I've got 4.5 squared plus c squared equals 6.6 squared. That's just a technique we do to put the unknown on the right side. Okay, so the left hand side. C squared equals 6.6 squared. Now we just need to start isolating it. Minus 4.5 squared. Okay, so c squared, where my calculator go? There we go. Okay, so c squared is 6.6 squared minus 4.5 squared. That's going to give me 23.31. Okay. Ignore that big black line. Jump down a few bits. C, remember when we bring over the power, okay, it becomes a root. So that becomes root of that answer, 23.31. So C, the unknown side, is going to give us 4.83 centimetres. Okay, I've taken that to 2 decimal points. Okay, sometimes the question asks for a certain amount of decimal points. In this case, it doesn't. So you can see the answer there is left in 1. I've taken it to 2 just to be careful. If you leave it in 1 or 2 and they don't decide, then that's absolutely fine. Okay, don't really go past that. Okay, so I've taken it to 2 decimal points. That's fine. Okay, so that red side there, now missing side, okay, in our equation we called it C, is 4.83 centimetres. Now that's not the finish of the question, okay? We want to find the total height. So we're going back to that circle. We've found that missing side, but we have to add on the radius. Okay, so the distance between the centre of the circle to the top there. Okay, and that will give us the full height of that label. Okay, now the radius given in the question is 6.6. So the height is going to be 6.6 plus our answer of 4.83. Okay, and that's going to give us our 11.43, or you can see the answer was 11.4. So they've just taken it to one decimal place, I've taken it to 2. They've not told me which, so that's absolutely fine if either or. Okay. Any questions on that stuff? Okay, those chord stuff. Some of the chord questions, and we'll do them later on, okay, get a wee bit more complicated. They throw a few more things in, okay, they'll put two circles together and stuff. You might have seen it on Tuesday when I was doing it. Perfect. I like you, Bill. Alright, you might have seen it on Tuesday, they add a couple of circles together, okay. When we're doing our revision towards the end, into end of March into April, okay, we'll look at more of those questions once we get more and more familiar. Okay, rest of the night I'm going to stay with Pythagoras for a wee bit. We can use Pythagoras in a couple of other different ways. Okay, the main gist of it's the same, it's that equation. Okay, so we'll go through Pythagoras again, just look at, see how else it can come up. Okay. Question. Okay, so yeah, I think you're thinking about the right thing, Dylan. Yeah. So what am I looking for? Pythagoras. Okay, so different ways they can use Pythagoras. I'm just going to use this as an example. Okay, now again, this is a past paper question, so sort of level that you're expected to do, but it shows you what it's asking. Okay, so take a wee picture of that somehow. Having a meltdown. Okay. Let's have a wee read of this and think about how we can use Pythagoras, okay? So we can use Pythagoras in 3D shapes, okay? So you'll get given some sort of cuboid, okay? A question centred around some sort of cuboid, okay? So in this case, it's a safe, but what we're looking at is that cuboid, that skeleton, okay? What it will ask you to do is connect two of the corners in some way. Okay, so if you look at what corners they're asking you to connect here, okay, they've labelled up one P and they've labelled one up M. Okay, so they are asking you to think about that shape in 3D. So if you've got any cuboids around you, it might be easier just to pick it up so you can look at the shape. Okay, it's asking you to go right across that and cut right through it. Okay, which is sometimes quite difficult to picture in your head. Okay. What it's looking for you to do is use Pythagoras to work out that missing side, and it will give you some amount of data. Okay, so in this case it's given us the dimensions of the top surface, okay, which in this case is square. Okay, so it's given us the dimensions here. They're outlined in red. Okay, and it's also given us the height, this one here. Okay, so with those bits of information, we have to find the distance from P to M, which, believe it or not, is a right angle, or a hypotenuse of a right angle triangle. Okay, now what we're going to do is use the information in the red square to find one of the corner to corners on the top surface. Okay, and then we can use the height to finish off that triangle. Okay, I wouldn't try and draw this in your pages. Just watch, and then, in fact, what question is this? I'll tell you the question that applies to, and you can go back to it. Okay, if you can draw nice cuboids, go ahead. Okay, but it might be easier just to watch that. Okay, so in here, I'll colour it in yellow. Okay, we've got a nice right angle triangle. P to M is a hypotenuse. M to top corner is one of the sides, one of the short sides, and then the same corner to P is the other short side. Okay, so imagine just slicing right through that. Now, they've put it in a nice wee story, which they like to do, but if you see a cuboid, okay, with that kind of data on it, that's what they're asking you to do. Now, ignore this bit at the bottom right now. We're just trying to figure out P and M. Okay, so as I said, I'm going to take this top square first that I put in red. Okay, that top square, and I'm just going to take it to the side. Hopefully I can draw a square somehow. Fair enough. I'm going to change that. There we go. Alright, imagine that's that top surface now. Okay. That's P. Oh, that's not M. That's P. Okay, so we've lifted that top surface off and we're looking from right at the top now. Okay, we get given information that's 40 centimetres and that's 40 centimetres. Okay, that tells us every side's 40 centimetres, it's a perfect square. Okay, so now consider what side or what line you're wanting to make now. Okay, so if we go back to the 3D model, I'm looking to create that line there. Okay, that goes from P to, I'm going to name this corner. What's the other one? MP. Let's call it N. I'm going to call that corner N, that corner there. Okay, so we can relate it. Okay, back over my drawing. I've now named that corner N. Okay, I want to connect P to N. Okay. And that's given me, oops, a right angle triangle, which means I can work out that length P to N. Okay, so I'm going to use Pythagoras once. A squared equals b squared plus c squared. Okay, so long side squared equals short side plus short side. Long side is pm. Short side 40 squared plus 40 squared. Okay, so pm squared is going to be plus 40 squared equals 3,200. That means the distance from P to N is going to be the root of that. Okay. Root of that answer. And that is in centimetres. Okay, so we're starting to build up the information we need to allow us to find P to M. So we've currently found P to N. Okay, so we've currently found that distance there. Okay, is 56.57. Now we want to take that information. We want to take P to N as a short side and N to M as a short side and create a right angle triangle with P to M, which I should probably draw as a straight line. Okay, a little bit harder to see, a little bit harder to imagine. It's still just a right angle triangle. Oops. Okay, I'm just going to draw that triangle out. Not in green. Okay, so I've lifted that right angle triangle, P to N to M, okay, that triangle, P and M, and I've put it down there, okay. Now we've worked out what P to N is, it's 56.57. Distance from N to M is 70 centimetres. Okay, that means the distance from P to M, because it's a right angle, A squared equals B squared plus C squared, P to M, oops, squared equals one of the short sides squared plus the other short side squared, which is 70. The 56.57 squared plus 70 squared. Okay, well done here with that specific, 8,100.2. PM, the length of PM, take the square over, 8100.2. Equals essentially 90 centimetres. Okay. So let's go back up to that question and work out why we've just found out what P to M is. Okay. So the locker, so that cuboid, okay, he's wanting to store an umbrella in it. Well, the umbrella is 85 centimetres long, and he wants to establish if he puts it leaning in there from corner to P to M, would it fit? Okay, so is he correct thinking it will fit into the locker? Okay, so if the umbrella is 85 centimetres long and P to M measures at 90 centimetres long, the umbrella will fit, so it is correct. Okay, so that justify your answer bit is the calculations that we did. Okay, so you cannot just say yes or no. You'll get no marks. Okay, so don't just take a punt. that won't get you anything. Okay, to get all the marks, you need to prove it, and by proving it, I mean doing all that stuff we did. Okay, and the final answer would be he is correct. Okay, the umbrella is 85 centimeters, and PM is 90 centimeters. That's your final answer. Okay, so sorry. Okay. So when you see a cuboid, when you see something like that, it's a case of just breaking it into different triangles. Okay, and there are always going to be right angle triangles in there. Right angle screams Pythagoras to you. Okay, as soon as you see a cuboid and it's asking you a question like that, or it's asking you to prove something, it screams Pythagoras. Okay. Any questions on that one? We're good? Other than just being scared by the 3Ds. Superb. Let's have a wee look. Okay, so one more type they could ask you, okay, is to prove again, okay, or determine one or the other. Another way they could use it is determine whether a triangle is a right angle. Okay, so a right angle triangle has to have a 90-degree angle in it. Okay, only right angle triangles is a squared equal b squared plus c squared, or the long side squared equals short side plus short side. Only in right angle triangles is this true. Okay, if there's no right angle in it, a squared will not equal b squared plus c squared. Okay, let's have a look what I mean. Okay, even if in the exam paper it looks like a right angle, go through the whole process. Okay, again, you're not going to get an answer, you're not going to get marks just by saying that is a right angle triangle without working anything out. Okay, just be aware of that. Okay, you could get given something like this, and you get given all the different sizes for it, and get asked, is this a right angle triangle? Okay, all you need to do is say, if it's a right angle triangle, then a squared equals b squared plus c squared. Okay. Taking that away to one side, then a squared is the longest side squared. Okay, so in this triangle, that would be 1.3 squared. Okay, and that would give you 1.69. Okay. Take that bit away to the side as well. If you were to do b squared plus c squared, that would equal 1.2 squared plus 0.5 squared. Okay, which will give you 1.69. Okay, that means a squared equals b squared plus c squared is true. The triangle is right angled. Okay, another way I would write that out, so instead of splitting it up, okay, like I did there, you could just write for it to be true, okay, for it to be true, a squared equals b squared plus c squared has to be true. So 1.3 squared has to equal 1.2 squared plus 0.5 squared. 1.69 equals 1.69, and that's true. Alright, so the seesaw is balanced. Remember that equal sign means the left hand side has to equal the right hand side. Okay, so for that triangle to be right angled, the left hand side has to equal the right hand side. I'll show you an example of where that's not going to be the case. Okay. Let's consider we get given a triangle that looks like it's a right angle. Okay. We're given that. Okay. Again, same question would exist. Is this a right angle? That says triangle. Take my word for it. Okay. Now you'd go through the same process. So for it to be a right angle triangle, a squared would have to equal b squared plus c squared. Okay. Now a squared is always along your side. In this case, that's 6. So does 6 squared equal 3 squared plus 4 squared? Okay, you can do this in your head if you want. Okay, 36 equals 9 plus 16. Okay, so that is not true. So the left, for this triangle that you were given, the left hand side does not equal the right hand side. Therefore, it is not a right angle triangle. You can only use that equation. The left hand side will only equal the right hand side if it's a right angle triangle. Okay, so the answer is no. Now, how they would ask that in an exam? Something like this. Okay, now there's a lot going on here, but that's essentially just the same question we just did. Okay. Triangles A and B are shown below. Okay, and it gives you all the dimensions. The triangles are placed together to form A, essentially A plus B. Okay. Is the large triangle right angled? Justify your answer. Okay. So it's obviously not asking you just to look at that triangle AB and say yes or no. It's asking you to actually work it out mathematically. Okay, so it's asking you to fill in that data in that AB triangle and then use that to establish the answer. So if we pick that side there. Okay. It's just that 8 centimetres. We back that side there. And look above. Okay. That's just that 19 centimetres. Look at the bottom. Okay. That side there. That's going to be that part of B plus that part of A. Okay, so it's going to be that full distance. It's going to be 16 plus 6, which is going to give you 22. Okay, does everyone see where that's coming from? Is the larger triangle right angled? So exactly what we did 2 minutes ago. If it's right angled, then A squared must equal B squared plus C squared. That means the long side squared equals the 2 short sides. Okay. That means 22 squared would equal 19 squared plus 8 squared. 22 squared is equal to 484. 19 squared plus 8 squared is equal to 425. So it is not true. Okay. This triangle is not right angled. Easy. Okay, so proofs and try to work things out in a story, okay, are quite common using Pythagoras. Pythagoras itself, A squared equals B squared plus C squared, isn't a complicated equation. You do not get given it in your exam paper. Okay, you are expected to know that. Okay, and you are expected to use it to solve different things. Okay, you might get a couple of different questions. There's usually, or will always be a circle question where it's got that chord where you're creating that right angle. Okay, or you might get asked to prove something or give evidence to something. Okay. So we look. Just going to go into the tracker that you've all got. Okay, so I've sent that out and just see where we've just been doing. Okay. In fact, is that showing that screen? Sometimes a bit funny. Yeah. Alright, so on that tracker, that zeta tracker thing I sent out, okay, we're looking at section 19, Pythagoras. So you can see the converse of Pythagoras, that's just that prove thing, okay, so you do your longest side, and then you do your other sides, do they equal each other, okay? Or they could ask it in a circle, like we were doing on Tuesday, or they could ask it in a 3D shape, okay? In this, all they've done here is they've tried to be smart essentially and do it all in the one line, do it in 2 different triangles. Okay, so in this case, we've got a triangle here, which is B to A. That's what you're trying to figure out, or A to B would make more sense. Alright, you're trying to figure out that line to A to B. You're given data, again on the outside 9 centimeters, 12 centimeters, and 8 centimeters. Okay, that diagonal along the bottom, A to that opposite corner, okay, that's the hypotenuse of 9 centimeters and 12 centimeters. Okay, so you'd be doing 9 centimeters squared plus 12 centimeters squared, then rooting that answer to get that hypotenuse. Okay, once you've got that hypotenuse, that becomes one of your short sides, added on to to that 8 centimeter squared short side, and then that will give you your hypotenuse AB. Okay, so again, break it into two. The way they've shown it here, they've tried to be smart and tried to skip a step. I think that just looks a wee bit. In fact, don't do that. Alright. Another one that we've not done is really quite rare, okay, and it's the distance between two coordinates. Okay, we'll cover this when we're doing revision. I won't cover this now. Don't be put off by that equation. Okay, all that they're asking you to do between two sides is work out the distance in the x-axis between two coordinates. Okay, that's one of your short sides. So you'll be the distance between the two x coordinates squared plus the distance between the two y coordinates, your up and down, okay, squared, and then root of that, and that will give you your distance between two coordinates. We'll look at some of them when we start revising. Pardon me. Okay. Okay, so what we're going to look at next, it's a wee bit of a night, is adding on to the rules that we learned about the chord. Okay, so we're going to look at the circle and we're going to add a few more shapes in there. Okay, don't be put off, don't worry too much. Okay, it's absolutely fine. So we'll go over these. So we're going to go over section 18 essentially. Okay, so to do that, we need to add a wee bit more in. Okay, now again, this is revision for that 5. Okay, this is assumed knowledge. Okay, so in that 5, technically it shouldn't be taught, but obviously a few of you haven't done it for a while. Okay, and it's the revision of something called SOHCAHTOA. Okay, so this is the first introduction to you, okay, or for you, introducing you to sine, cos, and tan. Okay, these are just trig functions, and we'll look at them in more depth. Okay, we can draw graphs of them, we can use them in circles. Okay, don't be too worried about these. They're just a button in your calculator. Okay, some people get really thrown by sine, cos, and tan. Okay, don't worry too much about them. Just treat them as a button in your calculator. Just treat them as an unknown. Okay, something we can move about an equation. Okay, now SOHCAHTOA is a way of writing out equations that can be used for right angle triangles. Okay. Only right angle triangles. Okay. Now, what the SOHCAHTOA means is the sine of the angle equals the opposite divided by hypotenuse. Okay. The k bit is cos the angle equals adjacent, I'll write that fully out, over the hypotenuse write that out if you missed it. Can't spell opposite. Probably makes it more confusing. Okay, in the TOA part, is the tan of the angle equals opposite over adjacent. Okay, so that's SOHCAHTOA, sorry, I'll write that. That's SOHCAHTOA. When I say SOHCAHTOA, it's just a wee thing to remind you of the order of those equations. Okay, now we can use those equations to find out unknowns in a right angle triangle, only in a right angle triangle. Okay. Let's have a wee look at how we use them. Okay. We'll do this for 15 minutes and we'll take a wee break. A right angle triangle. We've got the hypotenuse in this case. Okay, we get given the angle in here, which is 48 degrees. Okay, and we're asked to find one of the sides that is unknown. Okay, we're going to call that unknown side, put a letter, assign a letter to it. Now again, this could be any letter at all. Let's just sign P. Okay, I've not picked that letter for anything in particular. I'll just put P there just to say find side P. Okay, find the length of side P. Okay, now that's a right angle triangle, so if I see that, I know I can either use a squared equals b squared plus c squared, okay, but I've not got enough information. The fact I've got an angle there tells me that I want to use this SOHCAHTOA. So I'm going to write out, the first thing I do, I don't make any assumptions at this stage, I'm just going to write SOHCAHTOA out. First thing I want to do is establish where my right angle is and where my hypotenuse is. Okay. Now that might seem daft, but the hypotenuse is always opposite the right angle. Okay. So usually it's indicated by a wee square down the bottom. The hypotenuse is always across from it. It's always opposite it. Okay. So the hypotenuse is the longest side of a right angle triangle, and it's opposite the right angle. Okay. I then find the angle, or locate the angle that they're asking us to work with. Now that's really, really important, okay? Because the way that we apply the SOHCAHTOA rules depends on the angle that they're asking us to use, or the angle they're asking us to find. Okay, in this case, they've given us this 48 degrees down the bottom right here. Okay, now the opposite in these equations is the side that's opposite the angle that we're given, or we're trying to find. Okay. So in this case, side P is opposite this 48 degrees. Okay. That's our opposite. The adjacent The adjacent side is the side that touches the angle but isn't the hypotenuse. So in this case, that 48 degrees, you can see the hypotenuse makes up sort of one side of that. Okay, the other side of that line I've done in green there is the adjacent side. Okay, so in my calculations, that's going to be the adjacent side. Okay, so the hypotenuse will always touch the angle. The hypotenuse is always the one that's opposite the 90 degrees, and it's always going to touch the angle that they either give you or we need to figure out. Okay, the opposite will be the opposite side. Okay, in this case P, and adjacent will be the other side that's touching the angle that isn't the hypotenuse. Okay, and once we've sort of figured that out, and you should be able to do that quite quickly after a wee bit of practice. Okay, so once we've figured that out, and believe me, it's sometimes a common mistake to jump into the wrong equation and just start throwing numbers in. Okay, we can start going over to this SOHCAHTOA and work out what we're trying to find out and what we're missing. Okay, so it's asking us to find side P. Side P is the opposite. So I'll go to my SOHCAHTOA and I'll either tick above or below, and I want to tick just underneath the opposite. Okay, that's what we're looking to find out. Okay. We're looking to locate the opposite. That immediately rules out one of these equations. If we're looking to find an unknown, that unknown has to be part of that equation. So the SO part, the sine of the angle equals opposite over hypotenuse. The K part is adjacent over hypotenuse, and the tan part is opposite over adjacent. That means this K part we can't use, okay? It's not got the opposite in it, so we can't use it to find the opposite as an unknown. Okay. Going back over, that means it's down to 2. Okay. Now, what else do we have? Well, we've got the angle. Okay, so we can put a wee tick above this time. Okay, the sine and the tan bit. That means we can use the sine of the angle or the tan of the angle to find our unknown. So we get given that with a wee tick of that. Okay. The other bit of data we have is the hypotenuse. So again, we go back to that SOHCAHTOA and we can put a wee tick above that H because we've got the hypotenuse, and we don't have the adjacent. So we can rule that out. So we need at least 2 bits of these equations, okay, to work out the other bit that's an unknown. Okay, the third bit. So in this case, we've got the angle, we've got the hypotenuse, and we're going to use the SO part. SO is sine of the angle equals the opposite over the hypotenuse. Okay, and then we can just put in, so that wee symbol there, I think we've done it before. Okay, that wee symbol there is just the Greek letter theta. Okay, which is a circle with a big line through it, alright? That's the Greek letter theta. Okay, we all became pretty familiar with Greek letters, so I won't explain. Okay, but again, it's just a letter used for an unknown. So we can put in our angle, 48 degrees. Equals opposite. Okay, I'll just write OPP for opposite, divided by the hypotenuse, in this case 22. Okay, now it's a case of just rearranging that to get the opposite. Okay. Again, you can flip that. Okay, so put your unknown on the left hand side and just put all your known stuff on the right hand side. So we'll just flip that, keeping it the exact same. Okay, that and that's the exact same. We've just flipped it. That 22 is a divide on the left hand side, so it's going to become a multiple on the right hand side. So the opposite don't know why I've not used the letter P, but we'll just keep it. The opposite is going to be 22 multiplied by sine 48. You can put that in your calculator. Okay, so opposite equals your calculator. 22 multiplied, and there's a wee sine, cos and tan buttons all together. Pressing the sine button. In my calculator it shows SIN and then a wee bracket open, okay? In that bracket put 48 and then close that bracket. Okay, so we'll do that just to show that. So I've got, in my calculator I've got 22 SIN bracket 48 equals 16.35. I've not given any unit. Oh, I have. Okay, anyone not getting that in their calculator? We good?
I've got 1.506.
What's your there are a couple of different ways that can happen. Try again, exact same thing. So 22 multiplied by SIN 48.
I just keep getting the same answer. I've done 22 multiplied by sine 48, and then I even done the brackets as well, and it's still just showing me the same answer.
What could be the case is there's different modes that we can put calculators into, alright, for different reasons. It might just be set in the wrong mode.
Right.
What kind of calculator you got?
I don't know.
Okay.
Like,
See when we're in class on Tuesday. We'll just watch this and then we'll double check. Right.
Right, okay, I'll just write that answer down.
Is anyone else not getting 16.35? Cool. Right.
Why does it always just need to be me all the time?
So that gives you that one, 16.35. Okay. Now if I give you the exact same information, if I give you the exact same triangle, 22 is the hypotenuse, okay, and ask you to work out the adjacent this time. Okay, so if I give you the exact same triangle and ask you to work out the adjacent, we'd do the same process. So we'd go SOHCAHTOA, use SOHCAHTOA. Again, look at what we're trying to find. We're trying to find the adjacent. So we go over to our SOHCAHTOA and we've got a wee tick beside the A's, okay, underneath the A's. That's what we're trying to find. What information we got? We've got the hypotenuse. So I'll tick the hypotenuse here. That now immediately rules out a couple. So that first one, sine of the angle equals opposite over hypotenuse. Well, it's not got the adjacent in it, so we can't use that. Okay. then the tan of that angle equals opposite over adjacent. Well, we don't have the opposite, okay, so we can't use that. Okay, we've not got enough information. So we've ruled them out, so we have to use the cos. Okay, so as to find the adjacent, over hypotenuse. Okay, so I'll just shorten both of them. Putting in our knowns. Oops. Then working that out, so I'll flip it over. Putting that in a calculator, 22 times, and this time we're using the cos button, 48, and I'm getting 14.72, and I think it's in meters. Okay, so the adjacent side to that angle that we've been given, okay, is 14.72 meters. So you can see it's important that we label it correctly. Okay, so we need to be able to understand whether we're finding the opposite or the adjacent off the back of that. Okay, let's have a wee look. Give this a wee bash. What's the time? What's the time? Past. Do a couple quickly. Okay. So find unknown, find x. Again, x is just a letter I've used in place of an unknown number. Okay. Find x. What information do we have? This time we've not got the hypotenuse. Okay, so the hypotenuse alongside the one across from the 90 degrees we don't have. Okay, we get given this 18. Okay, so remember the side that touches the angle that isn't the hypotenuse is known as the adjacent. So this side here is my adjacent. Okay, the side opposite the angle that we've been given is x. Okay, so that's going to be opposite. Okay, so that's what I'm trying to find out. Got the angle and I've got the adjacent. I know it's a right angle triangle, so I can use SOHCAHTOA. The way I write it out, S equals, I put a wee small o and then a big H. That just reminds me that that's going to be divided. Okay, so sine of the angle equals opposite over hypotenuse. Okay, just write SOHCAHTOA, it's absolutely fine. The first letter after the sine, cos or tan, okay, is the one that you put on top of the fraction. Okay, so what one are we going to use? Well, we've got given the angle. Okay, so that doesn't help us any. We don't have the hypotenuse, however. Okay, we're looking to find the opposite, but we do not have the hypotenuse. So that rules the first two out. Okay, so we're trying to find the opposite. We've got the adjacent and we've got the angle. So we're using tan theta, okay, equals opposite, which is our unknown, over adjacent. Putting in our knowns, 38 equals opposite, and I'll call it x this time, adjacent is 18. Okay, flip that on its head, 18 equals tan 38. Move the 18 across. Put that in your calculator. Oh, 18 multiplied by tan this time, 38. Don't think it gives any units, does it? No. So that unknown there, what we've been asked for, okay, is the side opposite the angle. Work that out to be 14.06. Okay, just to finish off this, and I'll just draw a couple out for you to try. Let's see if this works. Okay, 3 triangles, all right angled. Okay, we give you angle of 63. X is my unknown, and the length of 24 there. Okay, so finding X in all of them. So 1, 2, 3. Okay. If I give you X, 19, and 43, so the angle is 43. Okay, do those using SOHCAHTOA. Okay, then take a wee break. So 2, 4, 6 minutes. Take a wee 10, 15-minute break. 20 minutes in total. Come back at let's come back at 25 to, okay. So 5 minutes to do those questions, and then we'll come back at, and then have a wee 10-minute break, okay. Let's come back at 25 to, guys, okay, 25 to 8. Nice one. Back together. Hopefully not too difficult. Let me just quickly run through these. Oh, it's not what I meant. Can you move that? Quickly run through these. So we've just all on the same page. Okay, so angle The unknown is that x, okay? That is opposite that angle, okay? The longest side is that 24 that we get given. So we're getting given hypotenuse, the side opposite the right angle, and we're asked for x, which is opposite the angle we're given. Okay, so we're getting asked for the opposite, and we have the hypotenuse and the angle. Getting asked for the opposite, we've got the angle, but we can't use that, we can't use that. Okay, can't use the cos because we've not got the adjacent. Okay, we can't use the tan because, again, we've not got the adjacent. Okay, so we can't use
Daniel,
Yep.
sorry, can you explain like the Sokotoa kind of method with me? Like, because when you're crossing bits out, I'm not understanding it, and then I'm struggling to make out what one it is that we use.
Yeah, of course. Okay, so on that triangle, the angle we get given, that x is the opposite of that angle. The 24 that I've got given is the longest side in that triangle, which is because it's across from that right angle. Okay, and the adjacent in these equations, okay, is the side that touches the angle. So you see how that touches the 63? The side that touches that angle but isn't the hypotenuse. Okay, so that's what my terms are, so opposite, hypotenuse and adjacent. Okay, now when we go over to this SOHCAHTOA, the SO part, the sine of the angle, and I use the Greek letter theta there, okay, equals opposite over hypotenuse. Okay, I won't write that out. The K part is cos of the angle equals adjacent over hypotenuse. Okay, and the TOA part is equal to tan of the angle opposite over adjacent. Now, when we get given data in a right angle triangle, if we're missing something or we get asked for an unknown, okay, they'll give you enough information to allow you to use at least one of these. Okay, you have to do that, you have to pick which ones, you have to determine which information they give you and what they're asking you to find out. Okay, in this case, it's asking us to find the opposite. So when it's asking us to find the opposite, I need to look at the SOHCAHTOA, but I need to break them up in my mind and say, right, which ones can I use to find the opposite? Well, I could use sine theta equals opposite over hypotenuse, or I could use tan theta equals opposite over hypotenuse, depending on what other information I've got. That immediately rules out the cos, okay? Because I can't find the opposite, so there's no point in using it. Does that make a wee bit of sense, Carla?
Aye, thanks so much. I don't know what way I was looking at it, thank you.
I know bother. All right. So what other information have we got? Well, we don't get given the adjacent. Okay. So if I look at the tan theta one, then we don't get given the adjacent. So that rules that out. Okay, because I need at least 2 bits of information to use it. Okay. So that now rules tan out, and I go back to sine. If I got enough information to use sine, well, I get given the hypotenuse in the question, and I get given the angle, so I can use that. Okay. Sine 63, okay, equals opposite, which is x. Okay, again, just a letter I use for the unknown, equals 24. I want to find x, so I want my unknown in the left-hand side just to keep it neat. Okay, so flip that equation round. Okay, so both of those lines mean the exact same thing, I've just turned it round. That allows me to move 24 over. Sine 63 that will give you 24, 63 equals 21.4. Okay, if I get any of these wrong, give me a wee shout. Okay, again, SOHCAHTOA, I always write it out. I'm getting asked for the hypotenuse. That immediately rules out the toe a bit. Okay, no point in being there. What information are we given? We've got the angle. Okay, and we've also got the opposite of the angle. So again, we're using sine. Okay, this is a wee bit different how we're going to rearrange this. So we're using sine again. Sine theta equals opposite over hypotenuse. This time the unknown is the hypotenuse. Okay, so sine 37 equals 14 over our unknown. Okay, now I'm not going to flip it this time. What I'm going to do is just move this x. Because it's in the bottom of that fraction, it's a divide on the right hand side. If I move that over to the left hand side, it becomes a multiple. It's just like what we did in the last question, except it's just a letter that we're putting in front of it now. So if I move that x over here to the left hand side, it becomes x times sine 37, okay, equals 14. Okay, I can move this whole term now over here. Now on the left hand side, sine 37, remember sine is just something we put in. It's just, imagine just putting a letter there. Okay, so it's a sine multiplied by 37, essentially what that's saying. Okay, so if I move them both together, I'm going to move them down and it's going to become a divide. So I'm going to have x equals 14 divided by sine 37. So I'm taking that whole term that I've got in that red box there. Okay, I'm taking that whole term. Because it's x multiplied by that red box, okay, if you imagine that, it's x multiplied by that whole term. I'm taking that whole term and it becomes a divide on the right hand side. Okay, that means x is equal to, putting that in the calculator, 14 divided by sine 37. So I'm getting x to equal 23.3. Okay, and that makes sense. The hypotenuse has to be bigger than that side, so that sort of makes sense in my head. Did anyone not do that movement correctly? Okay, or get something different there? Good, I like that. Don't really believe you, but I like it. Where did 3 go? Where did 3 go? There we go. Okay, opposite and hypotenuse, same one. I'll give you 3 questions that we use sine. Yeah, oh well, I've given you 3 questions that we use sine. Not the worst thing. SOHCAHTOA. Okay, we've got the hypotenuse, which rules out the TOA part. Okay, we're looking for the opposite again. So rules out cos part because it's asking for the adjacent. That means I'm giving you 3 questions in which you use sine. Which I don't understand how. Well, okay, so what have we got? Sine 43 equals x over hypotenuse 19. That's a nice easy one as well. Flip it, x over 19 equals sine 43. X equals 19 times sine 43. x equals 19 times 12.96. Again, one or two decimal places. I pick two there, pick one in the last one. It's what was that do? Aye. Nice one. Okay, so that it's assumed that you have that knowledge. I cover it because I know some of you might not have done it a few years and some of it might be new. Okay, so I cover it. If you're not sure in that, the best place to go is back to the BBC Bite Size in the National 4 section. And in the National 4 section, they'll go through SOHCAHTOA and they'll break it down for you a lot better. Okay, well, not a lot better, but in a wee bit of depth for you. So if you're unsure about what I've just been showing you there, go to that part. Now I'm going to show you how to find the angle as well. Okay, so I'm going to go through a couple of quick examples just to show you the angle, and then we'll blast into circles again. So that's 10 to 8, so I don't want to keep you too long. Okay, so we'll work till maybe 8:15-ish. Okay, so continuing to use SOHCAHTOA. Again, this is sort of continuing to build knowledge that National 5 assume you already have, but the way that this course is constructed, you might not. Okay, if we've got a right angle triangle, like so, if we have two bits of information, we'll nearly give you a sign question again. I'm not going to do sign. What can I put there? 14. Okay. If you get two bits of information, in this case two sides, I can use that to find an unknown angle. In fact, you know what? I'll put theta. Okay. So Greek letter theta is my angle. Okay. So I'm looking for an unknown angle. Again, I'm using the SOHCAHTOA. Remember, we can only use this when it's a right angle triangle. Okay. What are we looking for? We're looking for the angle. We can use any of them. Okay. What have we got? Well, we've got the hypotenuse. Okay. And we've got the adjacent. Remember, the adjacent is the side touching it. Okay. The information we're missing is the opposite side. Okay, so because we're missing the opposite, that rules out so and tan, so and toa. Yep, I'll get the link for you. Okay, someone just asked for a link for BBC Bite Size. Okay, so we're using cos. Cos theta equals adjacent over hypotenuse. Okay, now the theta bit's the unknown here, so cos theta equals adjacent, which is our 14, hypotenuse is 24. I want to leave theta on its own. So remember, theta is just a Greek letter, so like we use letters A, B, C, X, Y, Z, whatever in algebra, we can use theta. Theta is just an unknown. Okay, in this case it's the angle. Okay. Imagine that is this term cos multiplied by that term theta. Okay, that's what that wee bit means. So I can move just this cos. Okay, I can move this over to the other side here and leave theta on its own. Okay, so cos is a term, sine is a term, cos is a term, tan is a term that we can move across to the other side. Now what that is written as, it becomes cos to the -1. Okay, now if you look at your calculator, above the cos button, it might be written in yellow, it might be written in a different colour, okay? But above the cost button, it should say cost to the -1. That means if you press shift, which in my calculator is top left, so hopefully top left, okay, if you press shift and then the cost button, it should show you on the screen cost to the -1. Okay. I can then do cost to the -1, and then if you've not got a bracket already, put a wee bracket there and put 14 divided by 24 and then close that bracket. Okay, anyone not seeing that in their calculator? The answer you're going to get out, hopefully, is 54.3. And because it's an angle, that's going to be written in degrees. Okay, so degrees is the unit for angle. Okay. So we've found that angle in there. Now, I said previously you need to be careful when you're doing this, okay, and determine what angle they've given you, etc., or what they're looking for. So I'm going to draw out what looks like a very similar triangle. Okay, I'm going to give you the hypotenuse again. So let's say 32, okay, and I'm going to give you this side, which would be 17, okay. Okay, and I'm going to ask you to find this angle. Okay, so it's a right angle triangle. We know where the hypotenuse is. The hypotenuse is opposite the right angle. Okay, so 32 is our hypotenuse. Okay, we're getting asked to find x up in the top right this time. Okay, so the last question we did was down the bottom left, this time it's up in the top right. Okay, now if we do so Katoa and look at what it's asking us for, we're trying to find the angle, so we're looking for one of the sine, cos or tan. Okay, that doesn't give us much. Now we know we've got the hypotenuse, okay, so we can use either the sine or the cos one. It rules out the tan because we don't have the opposite, okay, so it rules out the tan. Now when we're looking at this angle, the adjacent still that side that touches the angle that we're looking for or working with that isn't the hypotenuse. So this is now the adjacent side. Okay, it's the side that touches the angle that we're working with, okay, that isn't the hypotenuse. Oops. Don't know why I wrote X. 2 seconds. Sorry if you'd written that. Sorry. Cos theta, let's stay consistent, is adjacent over hypotenuse. Cos theta, adjacent this time 17 over 32. Theta, bringing cos over. (57.9 degrees). Okay, I'll give you two, you can try on your own. Boom, 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 boom. So if you try and find this angle here, and I'll give you the hypotenuse, which is 14. I'll give you, which is, okay. Why do I have to keep writing X? Sorry. Give that a wee bash, and we'll put one more beside it. Okay. So find theta in both of them, please. And I'll give you a couple of minutes. Give it let's just take till 5 past, okay? Okay, just to finish this one off then. So, okay, what have we got? Well, we're working with this angle bottom right. We've got the side opposite, and we've got the hypotenuse. Okay, so we've got the opposite to the angle, and we've got the hypotenuse. Okay. That tells me I'm going to be using sine. Okay. Can't use cos because I don't have the adjacent, and I can't use tan again because I don't have the adjacent. Okay, so it has to be sine in this case. Sine theta equals opposite over hypotenuse. Sine theta equals opposite, which is 10, hypotenuse is 14. Moving sine across, it's written as sine -1, 10, 14. Okay, and that just goes in the calculator again, pressing shift, and then the sine button, and it should show you sine to the -1 on your calculator. Put a bracket in if you don't already have one. 10 divided by 14, close that bracket, and you should be getting 45.6 degrees. Very close to right level. Okay. Again, so anyone's still copying, give me a wee shout. Okay, so Katoa, what have we got? Angle top right there. We've got opposite, okay, which is 9. We've not got the hypotenuse this time. Remember, the hypotenuse is the longest side that's across from the 90. Okay, we've not got that. This time we get given adjacent, okay, 7. Remember, the adjacent is always the side that touches the angle that isn't the hypotenuse. Okay, so we've not got the hypotenuse, so that rules out sine, it rules out cos. We're using tan. Tan theta equals opposite over adjacent. Oh. Tan theta equals opposite, which is our 9. Adjacent is our 7. Theta equals tan to the -1. 9 divided by 7. Putting that in our calculator, shift tan bracket 9 divided by 7. What are the angles in the 50s? 0.1. 52.1 degrees. No trouble at all. Okay, 52.1 degrees. Okay. Any trouble? BBC bite size. Okay, so Pythagoras is used in circles, okay, when we find the chords. So what we did on Tuesday, when we found the chords, we can cut it in half and create a right angle triangle from it. I missed the answers to the first two. We missed sorry, someone just missed the answers, so. To be fair, I did say come back at 5 past, so it was myself just getting bored. Cool, cheers. Okay, so I'll leave that up. What we want to look at now is I'm going to introduce a few more ways they can ask you about circles that isn't the chord question. Now, the chord question, the one where you find the height of the label or the tunnel in their case, or find the depth of the water, they should be quite clear. They usually give you a wee story and they make it quite obvious that's a chord question. The other type of question they like to ask when they're putting in circles, okay, look quite intimidating, but if you work through them, they're actually not too bad. Now, what we're going to do now for the next 20 minutes or so, work till half past, okay? Next 20 minutes or so is this section 18, okay? Now you can see there's not a lot of places they can go with this, okay? So when I show you the questions, again, don't be scared, alright? It's probably the best way to put it. So let's find a question. One. Okay. This is the type of question that you'll get in the exam. So it's got a circle, it's got plenty of angles, and it's got plenty of lines. Okay. Now, what we're going to do and what it asks for is it will ask you to find an unknown angle. Okay. So we're going to go through some different rules that we need to know. Okay. Pythagoras was one. Okay. Understanding right angle triangles and when they come up in a circle. SOHCAHTOA, very rarely used, but you need to be aware of it or that type of work in it, okay? And we'll go through a few more, okay? But that's the type of question we're working up to. What looks quite intimidating, but actually I quite like, all right? 3 marks is quite nice. Okay, so. Okay, so back to this. So, a couple of things we need to be comfortable with, clear with, okay, when we're looking at angles inside of circles, okay? So they like to add circles and triangles. Start off with a nice horizontal line, okay? Now if I have a line coming away from that, oh, that's not a line. If I have a straight line coming away from that, looks a wee bit squint, but that's meant to be horizontal, okay? Trust me. That splits that into 2 angles, okay? That angle there, and that angle there. Okay, so I'll call that one A, that one B. If I add angle A and angle B together, I'll get 180 degrees. Okay, so if you remember a circle is 360 degrees all the way around. Okay, that horizontal is 180. So if I take a line away from that horizontal and add the 2 angles together, I'm going to get 180 degrees. Okay, hopefully you've seen something like that before. Again, I can have a horizontal line instead of one line coming away from it. Okay. I can have a couple of lines coming away from it. A, B, C. Okay. Mess about with the colours. If I add angles A, B and C together, again, I'm going to get 180 degrees. Okay. That allows me to find unknowns. So, for instance, if I had that sort of setup again, and I knew that angle in here was, it's not 50, but we'll go with 50 degrees. Okay, and the angle in here was 60 degrees. Okay, and I got asked, find that angle, I've got theta in there. Okay, I would know that all those three angles add up to 180 degrees. So I would know that 50 plus my angle theta, my unknown, plus 60 is equal to 180. Okay. That means I can find that unknown. So again, just a Greek letter, that theta. I can move that 50 and 60 over to the other side. Mark that together, head it up. Okay. Just leave theta, my unknown, 180, minus, okay, because they're both positive on the left hand side. We'll become minus on the right. Okay. Theta would be, what's that, 110, 70. Okay, so just that simple thing, horizontal line, however many angles are there, they will all add up to 180 degrees. Okay, nice simple one. When we were doing chords, I described a chord as any straight line that goes through the circle that isn't a diameter. Okay, now that's really important now, okay, when I draw this out. Okay, because we're going to use the diameter and draw a triangle off of it. Okay, so that's a line that goes from one side of the circle to another side of the circle and also goes through the centre of that circle. Okay, indicated by that wee dot. That line we refer to as the diameter. A chord is any straight line that goes from side to side in a circle that doesn't go through the middle. Okay, a chord can't go through the middle. And the reason the chord can't go through the middle is if we use the diameter and we bring two lines away from the diameter, like so, and it meet at a single point, what we're creating is a right angle triangle. Okay, so another way to describe this is a triangle in a semicircle. Okay, semicircle just means half circle. Will be right angled. Okay, so this is just a rule we need to know to work out that question, that type of question that I showed you previously, okay, in the past paper. Okay, so we need to know that. So if the straight line goes through the diameter, or is the diameter, okay, so it goes through the centre of the circle, goes from side to side and goes through the centre. If there's two lines coming away to that and meeting at another point in the circle, then that is a right angled triangle. Okay. Now, don't need to draw these out. Oops. Weird. That can take any form or direction, okay? So as long as it goes through the middle, as long as it goes through the middle, we'll create a right angle. Okay. As long as it goes through the middle, as long as it's the diameter, two lines coming away from it, create a right angle. Okay. Create a right angle. Okay. So if it's a diameter, if it goes through the middle, and in the exam paper, it will either say or be really clear that it goes through the middle and it isn't a chord, okay, that it is the diameter. If two lines are coming away to that and meeting at the edge of the circle, it's creating a 90-degree angle. Okay. Another rule for circles, we need to add, help if I draw a circle. If I have a circle and I have a straight line on the outside of it that touches it at any point, so that straight line like that straight line is touching the circle at that point, okay? Just skimming that circle, so it's not cutting through the circle, creating a diameter or a chord, it's on the outside of the circle and it's skimming that circle, it's just touching it at one single wee point that I've demonstrated there. That line, that type of line, is called a tangent. Okay, a straight line outside the circle touching the circle at one point. How we can use tangents, okay, is if we know where the centre is, and we bring a straight line from the centre to meet the tangent where it meets the circle, we are creating two right angles, one there and one there. So if we've got a tangent touches the circle, we can bring what is a radius from the centre of the circle to the tangent where they meet. It's going to create right angles. Okay. Again, tangents can come and go from any direction. All right. That's a tangent. Oops, that is not a tangent. That's a tangent. Oh my god. Tangent, okay. Then go and come from any direction. As long as it's a straight line, it touches it, the circle, a single point, okay, that's a tangent. The rule with tangents is if we know where the centre of the circle is, we can bring a straight line from that centre of the circle, cut the tangent, it will create two 90-degree angles. Okay. One last thing, I promise. Maybe. Triangles. If we've got a triangle like that, that is not a right angle triangle. That type of triangle is called an isosceles. So if we've got, I always spell this wrong, isosceles triangle. Okay. What an isosceles triangle is that angle there is the exact same as the other angle in the base. Okay. Now that happens if this side here and this side here is the same length. Okay. So the two angles in the base from an isosceles triangle are the exact same. Okay. We'll see a couple of isosceles triangles come up, and I'll show you where they come up. Okay. We've seen them previously with chords. Okay, if we've got a chord and we bring two radiuses to the point, that would be an isosceles triangle. Okay, both of those angles would be the same. So if we're using an isosceles angle, if we've got one of those angles, we know the opposite angle would be the same. Okay, again, they'll make that really clear in an exam if that's an isosceles triangle. And those wee lines that I've put through the triangle sides, okay, there's one method in which they'll show you that. So if you see a line, if you see a triangle like that and there's a line, one line on one side and one line on the other, cutting through the sides, it means they are the same length. Okay, so just be aware of that. Again, that will become apparent as more that we go through questions. Okay. So a few things there, a few rules there. What we could do is just jump into one of the questions. Okay, this is a free Nat Maths 5s. You should have a link to it, right? It's got all the past papers and stuff. I wouldn't try and use it yet, but this is where I get a lot of my stuff, okay? What we're doing. Okay, this is the one I showed you, wasn't it? Isosceles. Okay. So let's have a wee look at this question and just break it down and go through the rules that I just showed you. Oops. Okay. We'll do this together and then, Christ, it's 25 past. Oh my God. Okay, I wouldn't try and copy this or draw this. We'll print it out if we're in class together when we're doing the past papers. Alright. I wouldn't try going along, I would just watch probably. Okay, in the diagram below, ABE is the tangent to circle centre O. Right, so threw a lot of stuff at us there, so through letters and tangents and centre circles. Okay, so let's just break that down. Line ABE. On the diagram, we've got letter A, we've got letter B, we've got the letter E. Okay, A to B, B to E is line ABE. Simple as that. That's where that comes from. Alright, don't overthink it. Alright, might seem obvious, but that's where that comes from. Okay, so ABE. Line ABE is a tangent to the circle. Okay, it's touching the circle at B. Okay, it's a straight line. It's on the outside of the circle and it touches that circle at one point, and that's at point B. Okay. Circle centre O. So I said we'll make it obvious where the centre is. Okay. So any line coming away from there, okay, that touches that outside edge. So that line O to B, that line there, because it's the centre to the outside edge, O to B is the radius. Okay. The rule that I said when we were going through there is any line that comes away from the centre and cuts a tangent will give you two 90-degree angles. Okay, and that will become important in a wee second. Alright, now what else have we got on here? It gives us angle DBE. Now, I spoke about this on Tuesday. Okay, sometimes we're shown a wee thing like that. Oh, that's not A. And then writing like that means the same thing. Okay, so angle starting at D, go to B and finish at E. Okay, go to the diagram, start at D, we're going to B, and then we're going to E. That angle that's created, okay, is the angle that we're looking at there. Okay, now it says angle DBE is 58 degrees and it also shows you it. Okay, that's not always the case. They might tell you, but not write it in the diagram. So you need to be aware that DBE, the middle letter, will be the point of the angle. Okay, so angle DBE, the middle letter there is the point in which where that angle's sitting. Okay, again, just a wee thing. Okay, what are we actually getting asked? We're getting asked the size of the angle CAB. Find the letter C, find the letter A, find the letter B. Remember, the angle that we're looking for, the middle letter will be the point of it. Okay, so C to A to B, the angle that they've graded there is the angle that we're trying to find. Okay, so those rules we went over in the last 10 minutes, plus some of the understanding that we've got about chords. Okay, you can see a couple of lines there that we know as chords. Okay, with that understanding, we can build up all the different angles there, okay, to find the angle we're missing. Okay, so let's go for it. Right, so first one, we've got a tangent, ABE, radius OB, where they meet will give us 90 degrees. That angle there that I've done in red is 90 degrees. Now, that's split by that line BD. Okay, angle DBE is 58 degrees. So the rest of that I've drawn in blue, okay, that's going to be 90 minus 58. So that's going to be 32. Okay, 32 degrees. Okay, so that's our first angle. Decent start. Alright. Now, let's look a wee bit at this triangle here. This triangle here, I've drawn in red there, okay? What that's made up of is that line B to D. It's from one side of the circle to the other side, okay? It's not cutting through the centre, so that must be a chord. Now, at point B, we've got a radius, we've got a line that going from the centre to B. And at point D, we've got a radius, we've got a line going from the centre to D. Now that triangle that I've outlined in red there, that means that's an isosceles triangle. Now I know that because that line there and that line there are both the same length. They're both the same length because they're both radiuses. Okay. I mean that angle there is 32 degrees because it's isosceles. Remember the rule for isosceles, the base ones will be the same. Okay. Now that's 32 degrees, that's 32 degrees. We're missing one angle. We're missing this angle in here. Now all the angles in the triangle add up to 90 degrees. Okay, so if we're missing that angle in here, that I'll call V for no apparent reason. Okay. Then we've got 32 plus 32 plus V equals 90 degrees. Okay, because all the angles inside a triangle equal 90 degrees. No, it doesn't. My God. All the angles in a triangle equal 180 degrees. Okay, sorry, it's getting late. Cheers, Gary. Wide up. Alright, everyone adds up to 180. V will be 180 minus 64. Okay, so V equal 116. Okay. I'll move that out. Bring it there. Okay. 116 degrees. Okay. That seems like it's taking a long time. Don't worry, once you get the rules in your head, it's a much quicker process. Alright. 116 degrees there. Now we work out, or we're trying to work out this angle here. Now that angle there, we use the rule that any straight line, okay, with another line coming away from it, okay, that whole angle there will be 180 degrees. That means that angle in there that we'll call Z, because I'm running out of letters, will be 180 minus 116. 180 minus 116 is 64. So that angle in here will be 64. Unless Gary tells me otherwise. Right. Don't know why I'm rubbing that working out. Okay. Moving through the angles nicely. What have we been left with? We've got 64 degrees up there. Okay, now we've got another triangle that we need to play with. Okay, again, just using the same rules. Got this one in green. We've got this triangle here. Okay, go out a wee bit, see the full circle. That line C to B, again, is a chord. Okay, it's touching part of the outside, straight line, touching another part of the outside. Okay, so that's a chord. O to C is radius, O to B is the radius. Okay, so both of those lines are the same length. That means we've got another isosceles triangle. Okay. Rub that out. Okay, that means we've got another isosceles triangle. So that angle here, that we'll call R, and that angle here is going to be the same. Okay, those two angles I've just outlined there in green are going to be the exact same. Okay. All the angles in a triangle equal 180. Okay, so we've got 64 plus R equals 180. Tidying that up, this is just algebra. Okay, so 64 plus 2R equals 180. 2R equals 180 minus 64. Should have probably done this a wee bit further up. Take that away. Put that over here. Okay, so we've got this. Sorry. Okay. So this. Alright. 180 minus 64 is going to be 180 minus 64. 116. Okay, 2R equals 116. That means R is equal to 116 divided by 2. That angle then is 58. Yeah, that's fine. So if again, once you get good at it, you can jump a wee bit, okay, but don't try and get too smart. All right, I'm going really slowly through it, doing it all, okay, but that's essentially what we're doing here. Okay, so right in, nice and slowly, 58 degrees in there, and rub that out, 58 degrees in there. Okay. Again, it won't take you this long in the exam. You'll be good. You'll be well versed in it by then. Alright, 58 degrees, 58 degrees. Now we're getting closer to that angle we're wanting, CAB. We're getting closer to the end of the night. My word. Alright. What angle can we find now? So we're looking at this triangle now. Let's put in red. The angles we can find out will be this one here. Okay. And laterally we'll be able to find this one here as well. Okay. So we'll look at angle BCA first. Okay. Now, tidy that up a bit. (58°), okay. That line ACO, completely straight, okay, so that means where that 58° is, okay, the rest of that is going to add up to 180, okay, so that angle in there is going to be 180 minus 58, which is going to be 122. Okay, nice and simple. We've then got this mess down here. Alright. We've got line ABE, which is a straight line, and then we've got a bunch of lines coming off that. Now, we've got 3 out of the 4 angles. Okay. Now nothing changes there, because it's a straight line, all of those angles are going to make up 180. Okay. So we can go 58 plus 32 plus 58 plus our unknown, which we can call Q. I don't think we've used letter Q yet. Okay. Plus our unknown equals 180. Right, tidying that up a bit. 58 plus 58 plus 32 is 148. Got 148 plus Q equals 180. That means Q is 180 minus 148. Q is going to be 32. 32 degrees. Okay, that angle there is 32 degrees. The only angle we're missing, thankfully, is this angle here. Okay, CAB. Okay. Now, I've got 2 out of 3 angles in a triangle. Triangle adds up to 180. So I've got 122 plus 32 plus S equals 180. 154 plus S equals 180. That angle is equal to 180 minus 154, 26. Your final answer then is angle CAB (26°). That felt long doing it, so I can imagine watching it might actually send you to sleep. Alright, but hopefully you understood what I was doing there. Alright. When you watch these videos back, you can speed them up. FYI. Alright, so if you're trying that question again, you want to watch this back, you can speed it up. Okay, so those rules we went over, we used them all there. Okay, that's the type of question you'll get in the exam. Did I lose anyone? Anyone want to ask any questions? Or do we want to call it a night? Good. Happy days. Alright guys, appreciate it. I'll see you on Tuesday in the classroom. Any questions over the weekend, give me a wee shout.
Thanks, Daniel.
Cheers.
Thank you.
Thanks, Daniel. Bye.